Hi trig students, I miss you. I hope everyone is staying healthy. We're going to do section 8.3 today. So you can find the blank packet and then also my completed packet on our Blackboard page under content. And I know that we already did quite a few pages off of 8.3 before spring break, but we only had about half the class there. So instead of just doing the last half, I thought we would do the whole thing. So if you've already had this part, just fast forward until you get to the part that we left off on. And in the meantime, we're gonna start from the top. So in 8.1, we talked about applications of right triangles. And in 8.2, we talked about the law of sines. And now we're going to talk about the law of cosines. So remember that in section 8.2, we talked about the four possible cases of triangles, oblique triangles, those that do not have a right angle. In two of those cases, we use the law of sines. Well, we still have two other cases left. And so for those two cases, we are going to use the law of cosines. So those two cases would be side angle side, where your angle is included. And if you only have the three sides, side, 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 and no angles. Now there's no ambiguous case here. They always form one unique triangle. But this is an interesting point, that the law of cosines is only meant to be used on obtuse triangles. So if you remember your geometry, a right triangle has a right angle of 90 degrees. An acute triangle, or an acute angle, has an angle between 0 to 90, so a small little angle. But an obtuse angle has an angle somewhere larger than 90, but less than 180. So now we're going to be getting into some larger angles. Okay, so now still remember that all three angles do have to add up to 180 degrees. That's just the definition of a triangle, regardless of what kind you have. Now the law of cosines can be written in three different ways, as you can see here. And remember, the small lowercase letters, those are sides, and the uppercase letters, those are angles. So if we are looking for angle A, we would use this version. Angle B would be side B would be the middle version, and side C would be the bottom version. These are for sides. Now we can solve for angles if we have to, and that particular situation does come up with the side, side, side case, but we're not quite there yet. We're going to wait a few minutes on that one. So even though these look complicated, there's a pattern. So notice that if you are solving for a side, it's equal to the other two sides squared and added together. Then you have a minus 2 times the single version of those squared other sides times the cosine of the angle that's directly across from the side you're looking for. So it's actually a lot easier to remember these formulas than you think it might be. Okay, and then here's the law of cosines written in words. So let's talk about 4 possible triangle conditions, and let's talk about the laws used to solve those. So if we have a side, side, side triangle, we're going to use the law of cosines. Make a note, that's a My Math Lab question. Okay, if we have two sides and the included angle, that's why the A is in the middle of those S's, that's also a law of cosines. Make a note, that's a My Math Lab question. If we have two sides and a non-included angle, look at there's that word spelled backwards that leads us to the ambiguous case, that's the law of sines. And the fourth possibility is that we have one side and two angles, and it really doesn't matter which side we're given. That's the law of sines, and again, that's a My Math Lab question. Now, you can use a combination of both the law of sines and the law of cosines to solve these triangles. And that's what I like to do. Just remember, when you use the law of sines, you have to have 3 of the 4 variables. Also remember, law of cosines is for the obtuse angles. So this would be the larger angle of the triangle that's missing. Law of sines is for that smaller missing angle or that acute angle. That's important because sometimes if you don't follow that rule, you will get an incorrect number and then your entire problem will be off. Okay, so let's turn the page. Here we go. Now, notice that a special case of the law of cosines is the Pythagorean theorem. That's going to be on my math lab question for you. Now, you don't have to prove that, but you know I like to prove things. I think it's fun. So let's just look at that now. So let's say that we are given sides A and B and the included angle C, which happens to be 90 degrees. Well, this tells me we have a right triangle. So I'm going to draw that. Here's my right angle, and I'm going to label it C. That means I have C over here. And then I'm just going to fill in A and B all around. Okay, so now if I have been given A and B and C, I'm looking at an SAS, a side included angle side. That's the law of cosines. Okay, so let's solve for that side we don't have, which is C. So according to the law of cosines, C squared equals A squared plus B squared minus 2AB cosine C. Okay, now we don't know what A squared or B squared is. It says we were given that, but we don't actually have a value for it. What we do have a value for is cosine C. If we are told that C is 90 degrees, then we're going to put cosine of 90 degrees in. And if you remember your unit circle, the cosine of 90 degrees is 0. So multiplied by 0 means this entire term is going to go away, and we're left with C squared equals A squared plus B squared. Or if we rewrite it, there is our beloved Pythagorean theorem. And so that's actually where the Pythagorean theorem came from. That's how it was derived, was from the law of cosines using a right triangle. And we also know that we can only use the Pythagorean theorem with a right triangle. So there we go. Okay, let's go on to example 1. So example 1 says solve the triangle. We know that means we have to have all the values. Round the angles to 1 decimal place and the sides to 2 decimal places. Okay, well I'm going to go ahead and finish filling in these missing letters. So since I have a little b here, this must be angle B. A big C there means this is side C. And a big A here means little a. And there we go, that's what we have. Now, I notice that we have 2 sides and an included angle, which brings us to that SAS again, which is the law of cosines. So that's what I'm going to start with first. Even if I wasn't sure about whether or not I should start with the law of cosines, I know that if I wanted to start with the law of sines, I would have to have 3 out of the 4 variables. And I have 1 item from C, 1 item from B, and 1 item from A. So I can't use the law of sines even if I wanted to. I just don't have all of the information yet. So since I have side A and side C, I'm going to solve for side B. Well, the law of cosines for B squared is going to be the other 2 sides squared and added together minus 2AC times the cosine of angle B. And we have all of those values, so we're going to plug them in. A squared would be 9, C squared would be 25, minus 2 times 3 times 5 times the cosine of B, which is 36 degrees. Okay, let's clean this up a little bit. If you put this into your calculator, 9 plus 25 is going to give you 34, minus 2 times 3 times 5 is 30, times the cosine of 36 degrees. Now make sure you're in degree mode. You're going to get b squared is 9.729. Notice I said that b squared is that value, so we still don't have the side yet. We are going to have to take the square root of each side. And we see that side B is 3.12. Okay, well now we can continue on with the law of cosines, solving for an angle, which is a little more complicated, or we can switch over to the law of sines because we now have all the information for B. We have the side and the angle. So that's what I'm going to do. So I'm definitely going to use B in my calculations. Now I just have to decide, am I going to solve for angle C or am I going to solve for angle A? Well, that's important. It goes back to what we discussed on the first page, which is that the law of sines was created for acute angles, so smaller angles. You must choose the smaller angle. So since side A is 3, angle A is going to be the smallest. Because remember, the smallest side corresponds to the smallest angle. The largest side corresponds to a larger angle. So I'm going to put sine A on top because that's what we're looking for, and a 3 on the bottom. Then I'm going to put sine of 36 on the top over 3.12. These are the items for B. Then I'm going to multiply 3 times the sine of 36, and I'm going to divide it by 3.12. Now that doesn't give me A, that gives me the sine of A. So remember, in order to get A, we're going to need to use inverse sine. So in your calculator, you're going to need to put inverse sine, or second sine, 0.5652, and you're going to get that A is 34.4 degrees. All right, well, the only other thing we're missing now is angle C, and we can use the traditional law of triangles, which tells us that all angles have to add up to 180 degrees in order to find that. So angle C is going to be 180 minus 36 minus 34.4. And we see that angle C comes out to be 109.6 degrees. And we have solved our triangle. Okay. Let's flip our page over here and look at example 2. Okay, example 2 again has the triangle drawn for us. I noticed though that I don't have any angles. I know this is side A because it's directly across from angle A. Here is side C. Here is side B. And I have a side situation. Well, that's still law of cosines. And again, if I wasn't sure about that, I could try to put it into the law of sines, but I don't have all of the information for B, C, or A. So that's another indication I can't use law of sines. I have to use the law of cosines. Okay, so if I'm going to be using the law of cosines, that was created for the largest angle. So out of 7, 5, and 3, 7 is the largest. That means A is the largest angle. I'm going to use the law of cosines that contains angle A. Well, that just so happens to be A squared equals B squared plus C squared minus 2BC times the cosine of A. There's my angle A. All right, well, I have all of the other information, so let's go ahead and plug it in. I have A, which is 7. I'm going to square it and get 49. I have B, which is 5. I'll square it and get 25. And I have that C is 3, so I'll square it and get 9. Minus 2 times 5 times 3 times the cosine of A. Okay, well, if I take 49 equals 25 plus 9 is 34 again, minus 30 cosine of A. Now I'm going to subtract my 34 to the other side. And I get 15. 15 equals negative 30 cosine A. Now that negative 30 is the coefficient on the cosine of A. It's being multiplied by cosine of A. So the only way to get it off is to divide by negative 30. That's going to give me a negative 0.5 equals the cosine of A. Now we know that in order to get the angle, when we're given the value, we have to use the inverse. So we're going to use inverse cosine or second cosine of negative 0.5. This is going to tell you that A is 120. And that happens to be an obtuse angle, just like we thought it might be, which is why we use the law of cosines. Okay, so if I know that A is 120 degrees, this means I have all the information for A. So I can switch back to the law of sines just because it's a little easier, a little faster, a little less likely to make mistakes. So I'm definitely going to use A. I have to decide, am I going to solve for angle B or angle C? Okay, so remember, law of sines was made for the smaller angles, the acute angles. So C is going to be smaller than B because its side is smaller than side B. So I'm going to be solving for the sine of C, so it goes on top, 3 on the bottom, equals the sine of 120 on top, that's degrees, with 7 on the bottom. I'm going to make sure I'm in degree mode and multiply these two. I'm going to divide by 7, and I get that sine C equals 0.3712. Again, I'm going to take the inverse of sine, or second sine, 0.3712 in my calculator, and I come up with 21.8 degrees. Only one item left, and that's angle B. I can do 180 minus 120 minus 21.8 degrees. And I find out that B is 38.2 degrees. He was actually an acute angle also, so it would not have mattered if we had solved for angle B or angle C, but it's better to be safe than sorry. So we finished those. Okay, now example 3 does not give you a triangle. It just gives you some information. So we're gonna have to draw it. Okay, we draw a nice triangle. You can label these any way you want to. This is the standard labeling for the triangle. I don't have A, but I do have side A. I have angle C, but not side C. And I have side B, but not angle B. So I have a side, angle, side. That's a law of cosines. And again, if you weren't sure about that, I have to use law of cosines because I don't have all the information for a particular letter. Okay, so let's solve for side C. So in the law of cosines, solving for side C, we use this formula. We have all of that information, so we're going to plug it right in. We're going to square 6. We're going to square 9. We're going to do a minus 2 times 6 times 9 times the cosine of 130 degrees. Okay, if we put all of that in our calculator, we come up with C squared equals 186.42. We're going to take the square root of each side, and C is 13.65. There we go. Okay, now we have all the information for C, so I'm going to switch back to law of sines. And again, you don't have to do that. I just find it a lot easier when solving for an angle. Okay, well, if I'm going to use law of sines, I have to decide, am I going to be solving for angle A or angle B? Angle A is going to be smaller since side A is smaller. I'm going to put that on the top, 6 on the bottom, sine of 130 on the top, and side C, 13.65 on the bottom. I'm going to multiply, I'm going to divide, and I'm going to have sine A equals 0.337. Again, that's an inverse situation, so I'm going to do a second sine of 0.337, and that's going to give me angle A of 19.7 degrees. Now I have two angles. I can solve the third by taking 180 minus 130 minus 19.7, and I end up with angle B being 30.3 degrees. Okay, we are just moving right along here. We'll go on to example 4. Now there was a mistake on example 4. You know, I love to throw in little mistakes here and there. So we need to change some of these values. We need to change A to B4, and we need to change side B to 17. So make sure that you take note of that mistake. We've got to change both of those sides on that particular triangle, otherwise it does not work out, and we have a whole nother issue. Okay, so let's draw a triangle here. Okay. Do my standard labeling. Well, I just happened to notice that I don't have any of the angles. I have side A, I have side B, and I have side C. That's a side, 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 which also happens to be law of cosines. Again, I know it's not law of sines because I don't have all the required information for one particular letter. Okay, so if I have all the sides, that means I'm solving for an angle first. And when you solve for an angle using the law of cosines, it must be the largest angle. So that brings us to angle C because it has the largest side, which also means it has the largest angle. Okay, well, the only version of the law of cosines that has angle C in it is this one. Whoops. Make that a B. There we go. Okay, so we're going to plug in what we know. We know that side C is 19. If we square that, we get 361. Okay, we also know that A is 4. Square that and get 16. And we know B is 17 squared. I don't know what that is, so we're going to write it like that. And then we're going to do minus 2 times 4 times 17 times the cosine of C. Okay, now if we do square 17 in our calculator and we add 16 to it, we get 305. Minus 2 times 4 times 17 is 136 times the cosine of C. Now, you cannot subtract these two values. Some students want to do that, but this is a coefficient, so you're not allowed to do that. Your next move is going to be subtracting 305 from each side. When you do that, you get 56 equals negative 136 cosine C. Now we're going to divide both sides by negative 136. Move on up here. We get negative 0.4118 equals cosine C. Well, if we have the value, but we don't have the angle, we know that's an inverse situation. So we're going to do second cosine of negative 0.4118. And we see that angle C is 114.3 degrees. Ta-da! And there we go. Okay, so then all we would need to do to solve for the other two angles is you use the law of sines to complete that. So I'm gonna let you finish that on your own, but we're definitely gonna use the law of sines here. And then, do we choose to do angle A or angle B? We're gonna choose angle A because it's the smallest. So we're gonna put sine A on top over 4 equals sine of 114.3 degrees over 19. Multiply, divide, take the inverse, and so on. And I think you can take it from there. Okay, so now let's go down to example 5. Example 5 says, solve the triangle using either the law of sines, the law of cosines, or a combination. Be sure to note if there is 1, 2, or no triangles formed from the given information. And then we want to round. Okay, so in this case, we don't know what we're doing, and we could even end up with that ASS case, that ambiguous case. And in that situation, we would have to be really careful because we may end up with no triangles or multiple triangles. Okay, so let's see what we have. We need to draw a triangle. Okay, we're gonna label it. I see that I do have angle C, not side C. And I also have angle B, and I have side B. Okay, so as I'm looking over this, I have 2 angles and 1 side, and it's not a included side. So angle, angle, side is the law of sines. Now again, you don't have to remember or memorize which case goes with which law. What I notice right off the bat is that I have all the information for B. And if I have all the information for one letter, it's got to be a law of sines. So here we go. We're gonna solve for side C. So we put it on top. Over the sine of 97 degrees equals 20 over the sine of 37 degrees. We're gonna multiply, we're gonna divide, and we're gonna get that C equals 32.99. And there's our side C. Okay, now if we have side C, the other thing that we can do is go ahead and use the law of triangles to find angle A. We know that angle A is 180 minus 97 minus 37. Angle A ends up being 46 degrees. And then last but not least, we can use that information along with the given B information that we were given to solve for side A. So A over sine of 46 equals 20 over sine of 37 degrees. And I use this information for B here because that's what we were given. And just in case we got C wrong, I would hate to then also get A wrong just because we relied on a piece of information that we came up with. So when I multiply and then divide, I come up with side A is 23.91. And there we go. All right, well, we have 8 examples in this section. So let's go ahead on to our next page. Here we go. Okay, example C, same directions. We're not sure what we have, so we are gonna need to be really careful. Let's go ahead and draw a triangle. Here we go. I'm gonna do standard labeling on this. I see that A is 9 degrees. Oh, I really didn't draw that one correctly, did I? Well, just pretend that's what 9 degrees looks like. Okay, and let's see, side A is 11. Oh, good, I have all the information for A, so it looks like I'm going to be doing the law of sines. And I have some information for side B. So I have two sides and an angle. Well, ladies and gentlemen, when you have an angle and two sides, we know what we're talking about. That's the pain in the rear, right? That's the ambiguous case. So we're not really sure if we even have a triangle. And if we do we have one or two? So here we go. We're going to solve for angle B. So we're going to put sine of B on top over 20. We have all the information for A. So we're going to put sine of 9 degrees on the top and 11 on the bottom. We're going to multiply and then we're going to divide. When we do that, we're also, got a little ahead of myself here, we're also going to then take the inverse of that value, the second sine of that value. It turns out that B is 16.52 degrees. So we have at least one triangle. We have at least one triangle. So I'm going to go ahead and call him triangle 1, okay? And I'm going to call this B1, just in case. We may have another triangle. I'm really not sure, but I know we have one. If we came up with an error in our calculator, then we would have known that we do not, and we do not have a triangle there, so 0 triangles. Okay, so let's go on and find angle C. I'm going to call that angle C1. That's going to be 180 minus 9 minus 16.52. Turns out angle C is 154.48 degrees. Okay, now I still haven't checked to see if I have a second triangle. I'm going to do that in a minute. I just thought, let's go ahead and finish this one, and then we'll go from there, because we know we have one. So there's C1. Okay, the only other item we are missing then is little old side C. So if I put little old side C1 on top and sine of 154.48 degrees on the bottom, set that equal to what we know we have, which is all of A, 11 over sine of 9 degrees. Little side C1 turns out to be 30.29. So there we go. There's our triangle 1. Okay, well, let's check and see if we have, in fact, another triangle. Okay, could there be another one hiding? Well, let's see. We're going to check for a second triangle. Here we go. Now, to do that, we're going to take B2. We already found B1. It was right here. We're going to do 180 minus B1. Okay, this is B1. Well, we get a positive number. We get 163.48 degrees. Okay. Next thing we have to do is check for C2. In order to see if we have a C2, we better have a positive number when we do 180 degrees minus 9 degrees, this is A, minus B2. If this is positive, we have another triangle. And guess what? It is. There's our value, 7.52. So it turns out we, in fact, do have another triangle. Okay, I'm going to draw it in there. Usually the other triangle is kind of a weird little one, looks something like this. So here's A, here's B2, here's C2. Now the A is not going to change, it's 9 degrees. Side A is not going to change, it's 11. Side B is not going to change, it's 20. What has changed are these two angles, which we've already found, and this side. So we checked to see both of these were positive values. Now we're going to try to find little side C2. We're going to use law of sines to do this. We're going to put C2 over sine of 7.52 degrees. That's going to be equal to our A information because we were given that. And then C2 turns out to be 9.2. And there we go. We ended up with two triangles. We had the ambiguous case. All right, let's go on to example 7. Okay, same directions. We're not sure what we have. We're going to draw a triangle. We're going to check it out from there. So here we go. Do my standard labeling. Angle A is 66 degrees. I don't know side A. I don't know my other two angles, but side C is 17 and side B is 4. What I notice I have here is side, included angle, side. Not the ambiguous case anymore, thank goodness. So we know we have a triangle. Now we just have to know, are we using law of sines or law of cosines? Well, if you remember your cases, we're using law of cosines. If you're not sure, look and see, is it possible to use law of sines? Do you have all the information for one letter? Nope, have to use law of cosines. Okay, well, let's solve for side A. So using law of cosines, if we use the formula for A squared, this is what we're looking at. Turns out we have all of that information. So we're going to do a 4 squared plus a 17 squared minus a 2 times a 4 times a 17 times a cosine of 66 degrees. Okay, now you're probably experts at this by now, so I'm just going to put that whole thing in my calculator. A squared is 249.68. I'm going to take the square root of each one. And A ends up being 15.8. And there we go. We now have all the information for one letter. So I'm switching back to law of sines. Okay, which angle am I going to find though? Am I going to find angle C or am I going to find angle B? You better find angle B, because I'll tell you, if you find angle C using the law of cosines, you will get the wrong answer. Remember, law of sines is for acute, law of cosines is for obtuse. Okay, so I'm going to use law of sines. I'm looking for angle B, so sine B goes on top, 4 goes on the bottom, equals sine of 66 degrees over 15.8. That's my information for A. Multiply, divide. Remember, you're going to get that value equals sine B. So you're going to need to take the inverse of sine or second sine for that value. And angle B turns out to be 13.4 degrees. The last value we need is angle C. So we're going to do 180 minus 66 minus 13.4. And angle C is 100.6 degrees. And there we go. All right, I hope you're finding this very, very easy. Chapter 8 is very easy. There's just one example left. And of course, it's a word problem. So we need to make sure you're comfortable with this one. You're going to have it in your homework, in your quiz, and your homework review questions, should you choose to do that for your 5 bonus points. So here we go. We have a cruise ship. Here he is. And he's sailing from San Juan to Barbados, which is a distance of 600 nautical miles. So I know that's hard to read, but that's 600. Okay, the cruise ship is maintaining a speed of 14 knots. Well, that's just nautical miles per hour. Now, a nautical mile is a little different than, let's say, a land mile, but we're just going to go with it, okay? So now we see he's trying to sail up this way, but he can't because there's this really bad storm. So instead, he wants to avoid it. So he decides to go off this way. Okay, he heads off to the right a little bit at a direction of 14 degrees. And he maintains his 14 knot speed for 9 hours. Then the storm is gone. So he's going to go back and complete his path to Barbados. So 2 questions. Angle A says, part A says, what angle should the captain turn to head directly to Barbados? And then once that turn is made, how long is it going to take the ship to get there if he maintains his 14 knot speed? All right, well, I say the first thing we do is actually draw a triangle. So I'm going to draw a triangle that looks like this. Okay, I'm going to let B stay up there for Barbados, but I'm going to change this to A, which of course leaves this C. And that's where our ship is. That's our cruise ship, C for cruise ship. Okay, that means this is letter C, so it's going to be 600. Angle A is 14 degrees. Now we know the ship was heading in this direction, right? And so it's going to have to make a turn this way. And so that's actually what we're looking for, is this particular turn, not this angle C, this angle out here. That's what makes this problem tricky. Okay, well, first of all, we need this side because we can't do anything if all we have is a side and an angle. That's not enough information. Now we do have a little information about this, which happens to be side B. It's directly across from angle B. We know that side B, the cruise ship is traveling at 14 nautical miles, okay? And we know that it traveled 9 hours at this speed. So we need to solve for this. So let's just do a little proportion. That seems to be the easiest way to do this. So if we know that the cruise ship was traveling at 14 miles for 1 hour, right? 13 nautical miles per hour. How many miles did it travel in 9 hours? Okay, so we're going to do 14 times 9 divided by 1. Just so happens that cruise ship traveled 126 miles. All right. Well, now we have a side angle side. We have a law of cosine situation. Okay, so what we want to find is this angle. Well, we're going to have a little trouble finding that angle. So instead, what we're going to find is angle C. Once we find angle C, then we can do 180, since this is 180 degrees, minus angle C to find out what this little mysterious theta is right here. Okay, so first, let's go ahead and find side A. Well, we're going to use law of cosines to find it. So we're going to plug in the information we have. 126 squared plus 600 squared minus 2 times 126 times 600 times the cosine of 14 degrees. Complete that, take the square root. Don't forget to take the square root. I'm skipping that step, but make sure that you do that. You end up that A is 478.71. All right. Well, we're really close to finding C then. Now, let's see. Could we use the law of sines to find C? No, we can't. Because when I look at angle C, I notice that it's going to be the largest angle. And I can't use the law of sines with the largest angle. I could use the law of sines with B. I could find B, and then I could do a 180 minus to get this, or I could just go ahead and find C using the law of cosines. So that's what we'll do. We have to use the law of cosines since C is the largest angle. So the only law of cosines that contains angle C is this. So I'm going to fill in the values I have. Okay, I'm going to square both of these and I'm going to add them together. And then I'm going to subtract them from 600 squared. Then I'm going to divide by -2 times these two values. If you do all of that in your calculator completely, you should end up that cosine C is -0.953. So we're going to do a second cosine, inverse cosine on that value. And we end up with C equaling 162.4 degrees. Okay, so again, that is not the answer to letter A. Letter A wants this outside angle. So in order to find theta, this little mysterious outside angle, we're going to take 180 minus the 162.4. And despite my drawing, that ends up being 17.6 degrees. That is what we get for A. I'm sorry, for theta, for letter A. Okay, brings us to B. So once that turn is made, how long before the ship reaches Barbados? Okay, good question. All right, so we know the mileage. What we want to know is how many hours that's going to take. Well, we're going to go back to our trusty proportion. We know that the ship is traveling 14 miles in 1 hour. And we know that we have to cover 478.71 miles. What we want to know is how many hours that is. So we're going to multiply it by 1 and divide by 14. And that gives us x equals 34.2 hours. And we have our answers. All right, kiddos, that is section 8.3. So go on My Math Lab, get your homework done, and I will be posting 8.4 shortly.